I am Dr. BALA'S. In my last video, I have given the deficiency and the multi-system involvement. This one vitamin can affect various systems. What are the symptoms and signs you experience because of this deficiency? I have given a video in my previous video. Now, I would like to talk to you something about the absorption of B12 and how at various stages you can get problem. It's not like a simple vitamin, other vitamins. Just you take, you get digested, it gets absorbed. No. Vitamin B12 you take orally, it enters the stomach, goes to the small intestine. Where the small intestine ends, at that place, the ileum, only there it is getting absorbed. Do you know the distance between your mouth and this ileum? It is more than 20 feet. So this 20 feet, it has to travel. And remember, it's like a queen. It doesn't go alone. You cannot see a free B12 during this travel, this 22 feet or 23 feet. Somebody will accompany this. Somebody will act as a security, and this security usually is a protein. Various types of proteins, they take up this vitamin and they transport this vitamin securely till it is absorbed into the bloodstream. How? What are the stages? What are the steps? We can see. And remember, before that, I'll give you an example of a patient, and he is around 50 years old, and he has been suffering from diabetes for 10 years. That diabetes is type 2 because of obesity. So he wanted to go for a surgery, a bariatric surgery, where a portion of the stomach is removed. He had this surgery. He was more than 150. After the surgery, he came to 100 kgs. His diabetes was controlled. No more diabetes. He was not taking any tablet for that. But after the surgery, he was prescribed drugs. A surgery is a wound, an ulcer inside the stomach. Naturally, the ulcer can aggravate and the wound may not heal. So for that, we want to reduce the acidity of the stomach. For that, he was prescribed some acid reducing drugs. And this person was taking this drug for more than 8 or 9 years. Now he comes with symptoms suggestive of this vitamin B12 deficiency, this tingling sensations, this burning sensation, the shooting pain, the numbness, everything he has got. Now tell me, what are the possibilities that he would have got this problem? One is diabetes. Because of diabetes, he would have got diabetic peripheral neuropathy that has affected the nerves. Second thing, you would have taken metformin, the drug, for more than 5 or 6 or 7 years. That also can prevent the absorption of vitamin B12. He would have gone for vitamin B12 deficiency. Now, his stomach has been removed. So, the function of the stomach is partly removed. There must be a reason removing a part of the stomach and going for B12 deficiency. He was prescribed a drug, completely stops the secretion of the hydrochloric acid. This cause a deficiency of vitamin B12. So diabetic, metformin, a loss of a portion of the stomach, and a drug. All these things can definitely interfere with B12, and he may go for B12 deficiency. How? Before that, we will see the stages or steps involved in absorption of the B12. The source of B12 is, as you know well, not vegetables. So vegetarians and vegans are prone for this vitamin deficiency. If you take a non-vegetarian, the one organ which has got more vitamin is liver, because vitamin B12 is stored in the liver to the extent of even 5 to 6 years it can last. For example, you take meat, fish, or liver, anything from animal source. This B12 is not free when you take. It is attached to some proteins. So when it enters the stomach, this protein is digested and the free B12 is liberated. This digestion of protein is done by the hydrochloric acid, which is secreted by the stomach. Now the B12 is freed. But remember, the same acid, hydrochloric acid, can destroy the B12 if it is in the free form. Now, this B12 has to get attached to another protein for its safe transport. There are two substances there. One substance is there in your saliva, and also some of the stomach cells secrete. You call them haptocorrin. This is also a protein. The haptocorrin has got a very big affinity for the B12. So, this, like a security, it takes the freed B12. Now, this forms a complex. Those cells which secrete hydrochloric acid also secrete another factor that is called intrinsic factor of Castle. Castle is a person who discovered this factor. Even though the B12 can attach to the intrinsic factor, the haptocorrin has got more affinity, so it gets attached to the haptocorrin. The haptocorrin has got another name, or finder, and yet another name, transcobalamin 1. Now, the stomach is about 20 to 30 centimeter length. This haptocorrin and the B12 travels this along with intrinsic factor. The intrinsic factor accompanies this complex and they enter the small intestine. Now the stomach ends and the small intestine starts. At that place, the pancreas, which secretes some enzymes, they digest the protein haptocorrin and again the B12 is liberated. Now the B12 becomes again a free B12. But remember one thing, the B12, free B12 cannot survive or travel alone. It has to be securely transported by something or some material. Now, this intrinsic factor attaches itself with the B12. You get another complex now, that is B12 plus intrinsic factor of Castle. In fact, B12 has another name, extrinsic factor. These two, they travel about 20 feet, that is to the terminal end of the small intestine. You call it ileum. Up to that, the intrinsic factor takes this B12 and there the B12 is liberated. Now the B12 is absorbed by your body, enters into the bloodstream. Once it enters into the bloodstream, again the blood serum has got the same haptocorrin molecules. They get attached with this B12. They take up the B12. The affinity for B12 is very high. So 80% of the B12 is attached with the haptocorrin or transcobalamin 1. Only 20 to 25% they get attached to another protein which is called transcobalamin 2. So we have two portions, 80% of transcobalamin 1 plus vitamin B12 and 20 to 25% of B12 plus transcobalamin 2. This transcobalamin 2 plus vitamin, only that is a functional vitamin B12. When you measure the blood level of vitamin B12, total blood level, it includes both this 80% and the 20%. Even though you have a normal B12 level, but only this 25% are active, or I can say functional. So unless you measure this functional B12, transcobalamin 2, otherwise called holo TC, which is a complex of B12 and transcobalamin 2, your normal B12 level will serve no purpose. because 80% is inactive or non-functional, which cannot be used by the body. Now you know why I say B12 is like a queen. It enters with the protein, liberates, attaches with another protein, and this protein takes up to the small intestine. At the small intestine, intrinsic factor, another protein takes up this, and safely it is transported around the 20 to 25 feet of intestines, the large part of small intestine. If it crosses that particular area, it enters into the large intestine actually. Once if it leaves the small intestine, enters the large intestine, this vitamin B12 will not get absorbed. That is why I said, like a queen, it is escorted, it is securely transported by these guards, soldiers. Then what is the purpose of this transcobalamin 1 and B12, that's inactive form 80%? In fact, this is a circulating storage form of B12. Whenever the active form is less, the circulating storage form will give this B12 to the other to maintain that active form. So you have two storages as far as vitamin B12 is concerned. One is the liver stores up to 4 milligrams, 4000 micrograms, which will last for more than 5 years. Apart from that storage, circulating storage in the form of transcobalamin 1 or this haptocorin B12 complex. I think you will now know why I talked about the patient when I started this. That person, remember, he had a surgery, a part of stomach is removed. He was taking a drug for more than 10 years to reduce the acidity. He has been a diabetic. He has been on metformin. For this patient, there are a lot of reasons for this person to get B12 deficiency. So every aspect should be analyzed before we come to a conclusion. One. Second thing, when you know these steps, at any stage, starting from the intake and the digestion of this protein and liberation of B12, attachment with haptocorin, and then transport and release of B12, again with intrinsic factor, and then again release. So anything can happen in this 25 feet of travel by the B12, transport by the B12. So I have given us a nutshell of how B12 is absorbed, how complex is this absorption, and what are the steps involved in this absorption. And in my next video, we'll talk something about what are the causes which may interfere with this absorption and how to avoid that and what precautions we should take. Shall we see in the next video? I'm Dr. BALA'S. Thank you.